Good morning. Welcome and thank you for joining us here at KNX. Our topic today is going to be about integrating metering and supervision. And we'd like to welcome our guest speaker today, Roberto Rocco, who is going to be speaking about the integration of metering and supervision, so that you can understand more about the topic. Roberto is the business development and manager and for building automation at Ekinex, and Ekinex manufactures KNX devices which are dedicated to integrating metering and supervision. Thank you for joining us. Welcome, Roberto.
Thank you, Bob, and good morning to everyone. I represent the company Ekinex, which joined the KNX Association in 2011, and I thank you, KNX Association, for involving us in talking about smart energy management. In about 15 minutes, we will talk about the advantages to link two smart environments like home automation, KNX home automation, and metering. Everyone knows that buildings have a relevant impact on resources like energy and water. I'd like to mention three important European initiatives regarding smart technologies. The first one is about European directive. Metering systems and cost allocation methods exist since a relatively long time, but Directive 2002 of 2018 requires remote reading capabilities for heat meters, and that is to inform frequently end users, a very important point. The second initiative is quite recent because it dates back to September 2021. The guiding principle is called energy efficiency first, and among other things, it promotes the use of advanced technologies such as home automation and smart metering. But, very important, it requires to involve end users as active parts so that they can apply the guiding principle, so energy efficiency first, on a daily basis, that is in their daily life. Third initiative, it's about an indicator. Probably you know what I'm talking about, the SRI indicator, or Smart Readiness Indicator. It was introduced by the latest revision of the PPBD directive, and very important, domain number 9 is dedicated to monitoring and control, and precisely to central reporting of energy use. But apart from European Union guidelines, directives, and national laws, which is our daily experience as end users? In 2019, this is Eurostat data, nearly a quarter of household costs was dedicated to housing, to water, to electricity, to gas, and to the other fuels. So imagine prices are rising also these days. And this is the largest household expense item for European families. So also our daily experience tells us that monitoring energy, monitoring water consumptions is very important. So smart metering could be an answer, but how? You probably know this chain. If you can't measure something, you can't understand it. If you can't understand it, you can't control it. And if you can't control it, you can't improve it. This isn't a sentence of mine, of course, is attributed to an American businessman, author, improvement guru, and so on. But it's quite important to us. I'd like to point out one important feature of smart meters, the bidirectional communication. Originally, smart meters were developed and installed for supplier-side needs, mainly for remote reading for billing purposes. But today, smart meters offer interesting opportunities also to the end user side. Let's take a look at one example, and let's consider also, or above all, the critical points. The example is about heat energy. A metering system, how does it work? There's a reading of data. The data are transmitted to the building administrator. The building administrator calculates and allocates costs based on consumptions and send a cost report to end users. And usually it happens at the end of the heating season. Which are the critical points? A few of them are: the cost report arrives when the heating season is over, the attention of end users is often taken by extraordinary expenses and not by heating, cooling consumptions or hot sanitary water. The consumption is represented in monetary units. There is no reference to lesser or greater severity of the climatic seasons, and so on. Hard to believe, but an end user in the current year could be more energy efficient than in the last heating season and nevertheless pay more. He or she will probably be disoriented by that. So back to the missing link. Ekinex home automation can fill the gap. In which way? For example, informing end users about the consumptions more frequently in a graphical, easy to understand way, without additional standalone displays, usually delivered by each utility, and whereverable, including information about energy production, because we have to keep into account that the profile of end users is evolving from mere simple consumers to prosumers. That means producer and consumers at the same time. Home automation and smart metering, the focus of today. Since a while, Ekinex offers a supervision system by the name of Telego. It has been developed for controlling and monitoring of Ekinex installation, of Ekinex bus functions. The heart of the supervision system is the Telego server, as it is a compact device for mounting on DIN rail, and the end user interface may include several solutions. For example, an app for mobile devices like smartphones or tablets, wall-mounting touch screens, PC and laptops. Now let's take a closer look at the preview of the new function. That is the integration of metering data in our supervision system. Several metering categories can be defined depending on the building system. For each category, several meters may be added. In this example, energy meters. Today, homes can tend to be equipped with systems based on renewable sources, able to produce energy on-site. And in this case, meters can be used for both purposes, consumption and production of energy. So the end user could take a look at the energy balance of the building, could regularly check this balance and compare it with the project forecasts. Thanks to a slider, you can open an additional page with trend graphs, probably easier to understand for an end user. An end user could choose the reference periods freely, could be maybe a single day, or a week, a month, or a whole year. The color of the top bar immediately shows the end user whether the consumption is in line with the average consumption, higher or lower than expected. Pie charts allow to understand at first sight the share of energy produced, for example, with fossil fuels, and the share produced with renewable sources. Having a single interface for all technical building systems, so a supervision integrating also the metering data, is very important because it grants, for example, the highest rating calculating the SRI indicator. The principle is all domains in just one interface, a single interface for the end users. With this function, we would like to raise the end user awareness about their energy behavior. Some examples, just an idea. In watching them, please take into account that systems, devices, needs depend on several factors like countries, markets, available energy sources. So they are just examples. Gas boiler generation is today quite common in many countries. We produce, of course, energy for space heating and hot sanitary water. And the gas boiler is sometimes combined with a solar system. Here, you can take a look at 3 different energy meters. We have, of course, in this home Ekinex home automation system, and we interface with the Ekinex supervision system. What could we represent in this way for the end users? For example, how is allocated the total energy basing on the end use, which percentage is dedicated to hot sanitary water and which percentage is dedicated to space heating. From the point of view of sustainable behaviors, we could recognize in a very easy way the contribution of the renewable sources, because we produce hot sanitary water and this installation also with a solar system. And this share is represented in green color. A second example, many new or renovated homes have a heat pump. So heat pumps are used for heating, for space heating, for space cooling, and for production of hot sanitary water. And very often the heat pump is combined with a photovoltaic system. So in this case, we probably have electricity submeters and not energy meters. Also, in this case, we interface the energy meters with the Ekinex supervision system. And we can, in this case, know how the total energy, in this case electricity, is allocated basing on the end use. For example, there's a share represented in red for space heating, cooling, and hot sanitary water. And there's a share for the traditional electrical loads controlled by the Ekinex system, represented in light blue in this example. Once again, about the sustainable point of view. In green is represented the share of electricity produced on-site by a photovoltaic system. It is renewable, it is free for the end users. And in gray, the share produced just taking electricity from the distribution networks from the grid. It is probably produced with fossil fuels or with mixed fuels, and the end user have to pay for this electricity. Do not forget water, because water is a scarce resource. Less than 3% of the world's water is fresh, but 2.5% is frozen in Antarctica, in Arctic, or in glaciers. So A growing number of sustainable buildings will be equipped in the future with dual networks for water distribution. What does that mean? We will have water, high-quality water used for hygienic purposes, for cooking or for drinking uses, and we will use medium or low-quality water for many other uses. So think of an installation. In addition to the flow meters dedicated to cold water and to hot water, we will have a third flow meters telling us which quantity of grey water we use for those last uses. Uses for that we don't have to use high quality water. About sustainable buildings, just a few words, because there are several methods for the certification of buildings, for the sustainability certification of buildings. One of them is LEED in this example. The rating system includes 7 categories: focus on water efficiency and energy and atmosphere. So, for energy, the metering of energy consumption at the building level is mandatory, so is a prerequisite. You have to do it anyway. But you could have a further point if you plan also advanced energy metering systems. And we have no time, but it is written in the procedure that you have to inform regularly end users with that. The same for water efficiency. So at the building level, it is mandatory, so you have to do it. But if you install metering and also for the sun subsystems, you could have a further point. So from the point of view of sustainability, metering is quite important. Conclusions. Building design evolves, and evolves at a fast rate. Until 20 years ago, we just added technical systems to the building envelope. From the Directive 91 in 2002, so it's more or less 20 years ago, we began to design building envelope and technical systems as a whole. And for the next years, which will be the next step? Probably to involve the end users from earliest stage as active part. Doing that, integrating technologies like Ekinex, home automation, and smart metering will be more and more important.
Thanks. Thank you, Roberto, for sharing your 20 years of experience, as Ekinex on the integration of metering and supervision for sustainable buildings. I do have a couple of questions. I'd like to know, given the fact that you're using KNX here, how are the main objectives of Ekinex in linking the worlds of metering and home automation?
Yes, there are honestly more objectives in doing that. First of all, we'd like to raise the awareness of end users and help them to improve their behaviors when they deal with resources like energy and water, because these resources are not only scarce and expensive, but their user has a relevant impact on the environment. Secondly, thanks to the Ekinex home automation, we would like to represent metering data in a plain, understandable way for end users. We try to do it. That means, in my opinion, not representing rough data, because they are hard to understand for end users, but to, in a certain sense, convert rough metering data to useful information for end users. This is a challenge. Finally, we would like end users to understand that the contribution of renewable sources is crucial in the future for the sustainability.
And you mentioned end users. What type of information does the end user, get from Ekinex so that you have a chance to inform them so they can control?
Yes, as you probably saw in my slides, several types of meters will be integrated into the monitoring functioning the Ekinex supervision system. So since a few years, we have entered a new era in a certain sense, a phase of new electrification of buildings, applications such as heat pumps, photovoltaic systems, electrical storages, for example, or car charging stations are becoming more and more popular in new and renovated homes. So the data measured by electricity submeters are very important. Nevertheless, we have given the right weight to consumption and production of thermal energy, because we mustn't forget that on average, about 80% of the total energy consumed in a residential building is for heating and for the production of hot sanitary water.
Okay, well that's clear and certainly useful. And in terms of the smart energy, what developments do you see that will come about in terms of functions, in terms of
I think that this is an area with great potential for Ekinex. The solutions, not only what I told you today, but all the solutions presented in the Ekinex forum fully satisfy the needs of buildings that will be designed and realized in the coming years. In which we will have sustainable buildings powered by renewable sources, and end users who finally will be aware of their energy behaviors.
Well, we all want more sustainable buildings, so that's perfect. Thank you very much, Roberto Rocco, the building development manager and building automation at Ekinex. Thank you very much for joining us today here at KNX.
You're welcome. I thank you, and bye.